So hello, everyone. I'm Vic Perangelo. I'm the regional manager for ProSoft Technology. Um, I'm here today to talk about water and wastewater connectivity solutions. So water is a target industry for ProSoft, and I help focus on helping customers solve the challenges within this industry. ProSoft develops specific technologies for the water wastewater industry, and we have a global water wastewater affinity team, and I'm the leader of that team. So we know that this industry faces a unique set of challenges, from modernizing your equipment to connecting all the different types of pieces of your equipment, and that's exactly what I'm going to focus on today. So I'm going to take you through a smart water journey. And we're going to start out at the edge of this application, where you might have antiquated technology that you need to connect to newer technology. You might need to do this to better digitize your plant. I'm going to walk you through how ProSoft can connect dissimilar systems, leveraging different protocols, how we can help you improve data integrity of your system. I'm going to take a step back and show you how we can connect all of your automation at the network level, whether that networking is within the same plant or if it's geographically displaced across different assets. So just a quick note on ProSoft. We've been around for over 30 years. Actually, the company was founded in 1988 when our founder, Doug Sherrod, working for Chevron, needed to connect a PLC2. He needed to get Modbus data into a PLC2. So he cobbled together a gateway in his garage, and ProSoft was born. 34 years later, we have over 40 plus protocols with 160 different hardware combinations, whether they be Rockwell in-chassis modules or standalone gateways. So I'm going to take a look at the big picture here. This is basically the big picture of what water wastewater looks like. And there's going to be a lot going on in this image. When you take a look at this, I'm going to come back to this image often. I'm going to zoom into the technology that I'm talking about throughout all of these slides. So to get familiar with the general overview of what we're looking at, I know you know a lot of this already, but this is a freshwater application, and it starts out with fresh water, right? A canal, a reservoir, like you could see here on the bottom left. Then there's pump stations with automation, which is basically moving the water up through this image up to the treatment plant. This is likely where the SCADA lives. More functions, in the process there with batches of automation. You have clarifiers, you have filtration, disinfection, chlorination, etc. But just in this plant, you have different field devices speaking different protocols, some old, some new. What they all share, what all these processes share, is that they're all a critical part of the water wastewater process. Then you have outside the plant, right? You've got the pumps moving the water to the right in this image, moving the water towards the end customer, or towards the towers. So each part of this process has automation components. So this is a bird's eye view of what I'm going to go through. It's very similar to wastewater with all of these islands of automation throughout the process. The automation challenges, whether they're water or wastewater, are all the same. And through the journey, a lot of the smart water upgrades are the same. So the first step in this smart water journey is going to be improving and connecting through modernization. Okay. And in particular, I'm going to talk about phased modernization or phased migration. So what am I talking about? Lots of times you'll have a mix of old and new equipment, and you need to have the old and new equipment talk to each other. They might be on different protocols, legacy, antiquated protocols that don't exist anymore. But keep in mind the whole need for driving modernization in water and wastewater. There's several drivers that might cause the need to do it. The main one being digitization or connected water. I put this cartoon up here because listening to the news recently, I heard there was a water utility in Missouri where they interviewed a local government official, and he said this. He said, "Our water municipality consists of two old guys that used to be plumbers." Like, that was their qualification. So a lot of times nobody understands the old technology. And moving forward into smart water and digitization, these challenges of integrating new technology with old technology come together. So exactly what does this look like? Or what would drive you to do this modernization? So it might be product obsolescence, right? You just can't get the old parts anymore. It might be knowledge obsolescence. You can't find the people who understand the old technology. It might be the case where, when a system goes down and there's no equipment to replace it, somebody's getting a phone call at 2 a.m, and the next thing you know, you're sourcing parts on eBay. It's not really the thing you want to do, but that would be a reactive approach to modernization. A proactive approach might be more like, there's newer technology out there, it's faster, I can collect more data, it's readily available, people understand the technology. So more of a proactive approach to modernizing. But what exactly are you modernizing? You probably recognize some of this equipment here. This is legacy Rockwell equipment. We're talking PLC 5s, slicks, old 1336 drives, old panel view classic HMIs, and even the Flex IO on the obsolete 1794 ASB adapter. You just can't find these parts anywhere, like I said, other than eBay. So what do you do? Now, I used to be a system integrator, and my preference when ever doing a modernization was to gut everything, just rip everything out old and put in new. And that's really the way to go, in my opinion. But that includes, well, you have to take into account your budget, the downtime to do it, and the risk that comes with doing all that. So ProSoft has an option here that we call phased migration or phased modernization that allows you to do your upgrade in stages on your time and on your budget. So here's a quick example here. You may have some old PLC 5s on Bluehost, speaking Data Highway Plus or Remote IO, and they're connected to either the obsolete 1336 drive or the Panel View Classic or the Flex IO with the obsolete adapter. By introducing a modernization gateway from ProSoft, now what you're still on Bluehost out of the PLC, you have not touched the code in the PLC. The PLC doesn't even know you changed anything, but now you can introduce an Ethernet-based drive or an Ethernet-based HMI, and the Flex adapter, which is a 1794 AENT, which is an Ethernet adapter. It's a simple transition. Now you look at this and you say, well, this is great. I left the PLC alone and I changed the peripherals. What if I wanted to do it the other way around? And you can do that. This is literally like what I consider textbook migration. In this example, you have an old Slick 500 connected over remote IO network, Bluehost, to a bunch of remote IO drops. Now, traditionally, changing out all these remote IO drops is going to entail a lot of labor, a lot of money, a lot of time. So in a similar way, doing a phased migration, you can introduce that modernization gateway again, eliminate the Slick and add compact logics. And then when time and money permits, you can one by one replace all the drops until you basically changed out all the drops. And now you have, in fact, a new complete system. So you did it on your time, on your budget with reduced risk. What else can we do in terms of connecting legacy equipment? There's so much old equipment out there running on what you see on the left here are old legacy protocols, right? DF1, DH45, ControlNet, DeviceNet. Nowadays, everybody, especially when you're talking about SCADA systems, MES systems, they're talking Ethernet IP, OPC UA, MQTT. So ProSoft has the gateways that allow you to bridge from these legacy protocols to the current protocols. So here's what that looks like. Imagine you have a network or a system, you have two islands of automation. One is new, running on Ethernet IP, and one is old, like we showed before, PLC 5s or slicks on Bluehost. Traditionally, this system at the bottom is isolated and you can't get to its data, which is not good for any OEE or IoT digitalization strategy. So again, using that same gateway, you can now bridge between the two. You can have bi-directional communication between the old network on Data Highway Plus and the newer network on Ethernet IP. You can also now use your logics or links to get access to the old network through the new network using that bridge. So what I just showed you was all basically migrating, phased migration from old Rockwell, legacy Rockwell, to new Rockwell. We can do the same with legacy non-Rockwell to current Rockwell. So if you have Schneider's SCADA pack, which is big in water, or Texas Instruments, GE Genius, everyone listed here, you can do a similar phased migration as an alternate choice to a rip and replace. If I pick on SCADA pack, for example, customers working with old SCADA packs that are looking to upgrade, especially to an Allen Bradley system, the combination of some of select Rockwell PLCs combined with ProSoft's DNP3 router give you the functionality that you need in water. PLC with the MicroLogix 1400 has native DNP3 capability, but these other three don't. So by adding the ProSoft gateway, you now have the Rockwell PLC with DNP3 capability, which is DNP3 is big in water. Now, usually you can't talk water without somebody talking about DF1 and leased line modems, right? So I'm going to walk you through an example here. ProSoft has this DF1 router. Rockwell obsoleted their 1761 net ENI module back in 2017. So ProSoft has this DF1 to Ethernet IP gateway. And I see this used a lot in water, especially. And here is a simple example. So you've got some SCADA, some serial SCADA living on a network over lease line modems, talking to a bunch of serial RTUs. The way you would implement a phased migration on this is the first step is you would get rid of all those serial RTUs, replace them with compact logics like this, and you would need to add in the ProSoft gateway to continue to use the older lease line modem network. The second step would usually be to upgrade the SCADA to something Ethernet based. Now you have probably a PC based or PC based Ethernet based SCADA, and again adding the DF1 router. You're still utilizing the backbone of the lease line modems. And then the last step would be to eliminate those lease line modems. As you see on the right here, one by one, you could introduce some newer form of remote communication, whether that be 802.11 wireless or something cellular. I'm going to get to that in a bit. So if I look back, if I bring it back to the bird's eye big picture, we've just gone through and we've in the attempt of beginning a smart water strategy, excuse me, we've just modernized legacy systems through a phased migration approach. So what else could we do? The next thing we could do is we can improve the connectivity of disparate systems. Okay, so this is ProSoft's bread and butter, right? This is what ProSoft was founded on. Across any water utility, you're going to have different devices from different manufacturers using different protocols. You might have pressure sensors on HART. You might have flow meters on Modbus, the automation on DNP3. And then you may have a SCADA that's looking to see MQTT or OPC-UA. So in all these cases, you're going to need some sort of a conversion, some sort of a gateway to allow these disparate systems to talk to each other. So again, this is ProSoft's bread and butter. As you see in this image, you see an Ethernet IP system on the left with compact logics talking to a Modbus TCP IP network on the right. This gateway happens to have dual subnets, so you can separate the two networks. So that's another example of where we play in water, wastewater. If we go back to the original overview, we've upgraded the legacy equipment. We've connected different devices on different protocols. So the next step in this journey would be to improve data integrity. And one way to do that is by implementing DNP3. So what is DNP3? This is a distributed network protocol. So ProSoft's gateway, this one was introduced about a year ago. We have two. There's a DNP-S, which is a slave device, which you see here. There are a lot of features. It has a built-in SD card for disaster recovery. It has timestamping at the source. It supports DLR, device level ring. These are all great features that were custom built or implemented in this gateway for water applications. We also have a DNPM, which is the master module. So the master module can act like an outstation, so it can send multiple. It can be connected to a master SCADA, and then at the same time be connected to multiple DNPS units. Okay, so going back to the big picture again, we have migrated and modernized legacy equipment. We've connected disparate systems. We've added DNP3 for data integrity. The next thing we can do is improve in-plant connectivity. Okay, and the way we would do that is via ProSoft's purpose-built, very secure, very reliable wireless radios. So to take a look at what this would look like, if you look at this image on the right, you have the enterprise network talking to the control network or the plant network, and then you have these edge devices out here. So in lieu of trenching and pulling cable or fiber optic, if you're talking in plant, line of sight under a mile, you can put in a set of ProSoft radios, and now you can connect these edge devices back to the plant network. In addition to that, one of the nice things about using ProSoft Wireless and these purpose-built radios is that you can also enable mobile workers. So the ProSoft radio, and by the way, there's only one part number of the ProSoft radio. When you get it, you configure it either to be the master access point, or to be a client, or a client repeater. We have the IP20 versions of it that usually live in an enclosure. We have an IP67 rated version, which would be outside in the elements, unprotected. But as you see in this image, so now a mobile worker with a third-party client like a tablet or a laptop, he can now access the network locally without having to wire into it. So where this plays really well in water wastewater, if you see this example, this plant, you see that over sort of the center of all these buildings is where let's say the treatment plant would be. And then you have all these 10 or 12 clarifying pools. Each one of those clarifiers has automation on it. In this case, there's MicroLogic's controller on each clarifier arm, and we would add an IP67 radio out there. Back at the master radio, back at the SCADA, would also have an IP67 radio. Now, when you compare the example of installing 12 or 15 radios versus what it would take to trench, lay conduit, and lay out all the wiring that would be required to access all of these clarifying pools, the cost and ease of installation and deployment is extremely low. It also enables the ability to use mobile workers. It's very secure. There are a lot of ways we implement security. One is with industry standard WPA2 AES encryption. The ProSoft radios have something called secure bridging, which is basically only ProSoft radios can connect to the network. It wouldn't allow any outside radios to connect to the network. We have a feature called rogue access point detection, which basically would identify that there's what do you call it? Another radio on the line that's not supposed to be there. So we can also attenuate the signal, meaning the radio signal would be limited to just the area in which it's being used, so that it wouldn't necessarily be accessed by something outside of the area. So what else can we do in water? Well, so again, just to summarize, we've modernized legacy equipment. We've connected disparate systems. We've added DNP3 for data integrity. We have just connected in-plant automation, these islands of automation. We've connected them all through local wireless, the wireless LAN. And then the last thing we can do is we can now connect securely and safely connect your remote assets, okay? The pump stations, the lift stations, the water towers, the things that are not in plant, but maybe miles or tens of or 100 miles apart. And we do this through ProSoft's PDN, Persistent Data Network, which is powered by ProSoft Connect. It's the most secure, the most forward-looking solution in the market for connecting remote sites. So what does that look like? So if you look at here in the image, basically, we're leveraging the power of the cloud, computing power of the cloud, to create an always-on secure VPN tunnel, which is always on to all the sites all the time. These sites can be connected via cellular, or they could be connected via local wired internet. It's extremely secure. It's easy to use. It's quite often used with ProSoft's data logger. The data logger would be a device that's located at each remote site that logs data remotely at the site in the event that, for whatever reason, if communications are down, when the communications come back up, that you can now restore or backfill the missing data. But it's extremely easy to use. There's no software to maintain. There is no software. All you need for this is to create a ProSoft Connect account and have a web browser. We manage everything behind the scenes, which means you don't need to purchase an expensive server. You don't even need IT knowledge. You don't need IT expertise. We handle all that for you. All you need is a ProSoft Connect account and a web browser. So, and the deployment is extremely easy. I'm going to walk you through that right here. So the first thing you would need is to purchase the hardware, either a cellular modem, a cellular gateway, or a network bridge, which is the wired version that you plug into the local internet. That's here on number one. Number two is you create a ProSoft Connect account, and all you need to do that is an email address and a web browser. Once you have that, you would then create a project. You can think of a project as like being a customer. So if I was a system integrator and I had 2 customers and I wanted to separate them, I would create 2 projects. So you see here, like the city of Springfield is one project, and these would be other companies or maybe other customers of mine. And then after that, you assign the users and you give the users different access levels. So you tell it who can access this project or this customer and what level of access do they have. Are they administrator? They can do everything. Can they look only? They can look, but they can't make changes. After that, one of the features that ProSoft Connect has, it's a function called virtual lockout tagout. This is a very powerful, very secure, it's a feature aimed at security. When ProSoft developed this, we were sort of looking at 2 things, so ease of use and security. So it's extremely easy to use, easy to deploy, and it's very secure. And this is one of the features that makes it extremely secure, this virtual lockout tagout. Virtual lockout tagout basically allows the end user or somebody at the end user site, usually an IT person, to have total control over who has access to come in, to remote in, when they come in, how long they come in for, and what they're able to access when they're connected. And that's on a per connection basis, that every time somebody tries to connect remotely to the network, they've got to get through the administrator. They've got to tell the administrator when, how long, and what they want to see. And if the administrator doesn't allow it, they don't get in. That's pretty powerful. After that, once you're in, you can connect, you can see all the gateways, you can see through to the devices and the IP addresses. And there's very key metrics that come along with the system. It allows you to see things like there is an activity log that tells you who was in, who allowed them in, when they was in, when they were in, how long they were in for, and what devices they were looking at. So that's basically the end of it. That's the end of my sort of smart water journey. Again, we're involved in all aspects of it. So we've been doing this for a very long time. If you're looking to connect remote sites, whether they're in plant or geographically dispersed, if you're looking to modernize phase migration of legacy equipment with new equipment, if you have to connect different assets, different systems that are on different protocols, and if you want to improve data integrity with DNP3, these are basically the products we have that were purpose built to do just that, and they're deployed in water all over the place. So that pretty much sums it up for me. If you have any questions, feel free to contact your local account manager at HESCO. I've got the information up here, and that's about it. So thank you very much.